Welcome to the exhaustive technical masterclass on preparing a site lifting plan. This document is the absolute foundation of engineering safety and operational efficiency. Governed by international standards like LOLR and ASME, the lifting plan is a mandatory legal document that assigns total accountability for every hook movement on your site. The preparation is led by the appointed person. This individual must possess the technical mastery to calculate load moments, ground pressures, and equipment safety margins. Module 1, Classification. You must first categorize the lift as basic, intermediate, or complex to determine the required level of technical oversight and risk control. A basic lift involves routine operations where the load weight is verified, the center of gravity is stable, and there are no proximity or environmental hazards. Intermediate lifts involve hazards like restricted access or lifting near energized power lines. These require a rigorous spatial study and a more detailed method statement. Complex lifts are the most critical. They involve multiple cranes, personnel transfers, or loads that exceed 75% of the machine's rated capacity. Module 2, Load Identification. Accuracy is paramount. You must define every physical variable of the load before selecting your rigging and equipment. Calculate the gross weight. This must include the net weight of the object plus the weight of the hook block, all slings, shackles, and any spreader beams. Identify the center of gravity. An off-center balance point will cause the load to shift violently during the pick, creating dynamic forces that can cause failure. Verify all lifting points. Use only certified inspected lugs. If no integral points exist, your plan must detail an engineered slinging method to prevent load crushing. Assess the load surface area. Large panels can act as sails, creating enormous lateral forces. Your plan must include tagline control and maximum wind limits for these shapes. Module 3, Site Survey and Ground Preparation. A crane is only as stable as the ground it sits on. A physical geotechnical survey is non-negotiable. Analyze the ground bearing capacity. For mobile cranes, the pressure exerted by outriggers can exceed 100 tons per square meter. Ground strength must be mathematically verified. Check for underground hazards. Subterranean pipes, sewer lines, and electrical ducts can collapse under the crane's weight, leading to an immediate site catastrophe. The plan must specify the size and type of outrigger mats needed. Spreading the load over a larger footprint is the only way to ensure the ground remains stable. Define and secure your exclusion zones. No person or unauthorized vehicle should ever enter the lift radius. This requires physical barriers and dedicated site marshals. Module 4, Crane Configuration. Selecting the correct machine is a technical decision based on the load's maximum weight, required radius, and lift height. Consult the manufacturer's load chart. It is the ultimate authority, defining the safe working load for every boom length, angle, and radius combination. Determine the load radius. The horizontal distance from the crane's center of rotation is critical, as lifting capacity drops sharply as the radius increases due to leverage. Your plan must specify the required boom length and tip height. You must also account for the length of your rigging to ensure sufficient vertical clearance for the load. Specify the exact counterweight configuration. High-capacity mobile cranes may require hundreds of tons of ballast, which must be verified against the load chart before the lift. Module 5, Rams. This includes a step-by-step method statement and a comprehensive risk assessment that anticipates every possible failure point. The method statement provides a narrative of the work. It must detail every phase of the operation, from site setup to the sequence of the lift and safe dismantling. Define strict weather limits. If wind speeds exceed the plan's wind-off trigger, all operations must cease immediately to prevent dangerous load sway or tip over. Always mandate a trial lift. Raise the load just enough to clear the ground, then hold it to verify the crane's brakes and the integrity of your rigging gear. Your plan must include an emergency response. In the event of a mechanical failure, you must have a procedure ready to land the load safely and evacuate personnel. Module 6, Rigging and Accessories. Every component between the hook and the load is a potential single point of failure. Detail each one. Understand the physics of sling angles. A shallow angle increases internal tension exponentially. Your plan must specify the minimum allowed angle to prevent rigging failure. Every accessory must have a clear, safe working load mark. Your plan must match the rigging gear's SWL to the gross weight of the load with a safety factor. Specify spreader beams for oversized or fragile loads. They convert bending forces into compression, protecting the load and maintaining proper rigging geometry. Specify taglines for lateral control. Taglines allow the ground crew to manage load rotation without standing under the hook, ensuring total operational control. Pre-use rigging inspection is mandatory. Any gear showing wear, fraying, or deformation must be rejected and removed from the site area immediately. No exceptions. Module 7. Personnel and communication. A plan is only as good as the team executing it. Every role must be clearly defined and assigned to a qualified person. The lift supervisor is the command authority on the ground. They ensure the plan is followed to the letter and have the absolute power to stop work. The slinger signaler is responsible for secure attachment and is the only person authorized to signal the operator. Clarity here is the difference between success and failure. The crane operator must be qualified for the specific machine. They rely on the slinger's signals and the real-time data from the crane's safe load indicator. Conduct a mandatory toolbox talk. Every team member must understand the lift path, the hazards, and their specific duty before the machinery moves. Test your communication channels. If using radios, check for dead zones or interference. If using hand signals, ensure the operator has a clear line of sight. Use only standardized hand signals. This ensures that every command is interpreted correctly by the operator, regardless of site location or nationality. Empower every team member with the stop work authority. If any person spots an unmanaged hazard, the lift must stop immediately until the issue is resolved. Module 8. Execution and real-time monitoring. During the lift, the supervisor and operator must continuously monitor both the machine and the environment. The safe load indicator provides real-time data on the percentage of capacity used. If the SLI triggers a warning, the operator must follow the pre-planned recovery steps. Ensure the slew path remains clear of personnel at all times. Use exclusion zone marshals to maintain the integrity of your safe lifting corridor. When landing, the slinger must verify the load is stable before disconnecting the rigging. Unstable loads can roll or tip after the crane hook is released. De-rig with total care. Falling slings can be a lethal hazard. Return all accessories to their storage area and perform a post-use inspection for any damage. Module 9. Specialized operations. Some lifts carry extreme risk and require specialized technical protocols and significantly higher safety margins. Lifting personnel requires a certified man basket and a crane derated by 50%. This provides a massive safety factor for your most critical site operations. Tandem lifts require 2 cranes to move in absolute synchronization. The plan must detail the center of gravity relative to both crane hooks throughout the path. Most lifting accidents are preventable. A major cause of catastrophic failure is estimating load weight instead of measuring it. Never guess your hook weight. Complacency is the enemy of site safety. Skipping a ground check or a distribution mat can have fatal consequences. Stick to your plan every single time. Module 10. Logistics and traffic. You must manage site vehicle movements and have a documented rescue plan for every lift operation on your site. Ensure specialized rescue equipment is on standby. Speed is the critical factor during a medical or mechanical emergency. Preparation saves lives on site. Maintain a rigorous asset register for all lifting gear. Digital tracking ensures that only gear with a valid certificate of thorough examination is available for use. Hold a post-operational debrief. Every lift is a learning opportunity. Identify improvements for your next plan and update your site safety register accordingly. We have covered classification, load identification, site surveys, crane configuration, and method statements. These are your technical foundations for every lift. Along with rigging physics, team roles, execution monitoring, specialized lifts, and emergency planning, you now possess the knowledge to plan a world-class lift. Excellence in preparation is the hallmark of a site leader. Lead with precision, Prioritize safety and ensure every lift on your site is a technical success. For advanced technical templates, checklists, and more professional training resources, visit our technical portal today. Mastery of safety is just a click away. Plan for a safe tomorrow. Master the lift, master the site. Stay safe and lead your team with precision. Thank you for following this professional guide.